All right. Hello, everyone. Welcome to Math 154, Week 5, Lecture 2. Just going to take 5 to 10 minutes to talk about this whiteboard, especially the part that's at the bottom that you can already see, but let's get there in a second. So, per usual, we have our MyMathLab homeworks that are on the horizon. 3.1 and 3.2 are due on the 24th, which is likely today if you're watching it the same day as class. And then 3.3, the 29th, we finished that last time. 3.4, we will finish today, so that is due in a week on July 1st, a week from today's class. Remember, this is all being recorded ahead of time, so I'm actually doing all this on Wednesday. It's not Thursday where I am, but we're just going to pretend it's Thursday, right? All right, so Excel 2.4 CPI, that is due on the 29th. I had thought about going ahead and assigning the next one, but I'm gonna wait till next class. The same for a discussion board and the same for a quiz. I was really thinking about putting one or two of those three things up here for the next assignments, but we're just gonna lump them all in next class and kind of let some of these be taken care of as time goes. So that previous discussion board due on the 24th, the pay attention quiz due on the 29th. Remember, we talked about how you're supposed to answer these. And if that doesn't sound familiar to you, you need to go back and watch week 5, lecture 1's video. So the two things we'll spend a lot of time talking about today, in addition to finishing out 3.4, will be the project details. And we're going to do that a little bit later, but I want to point out that you're going to be making a budget for yourself. And the dates that you need to be budgeting your money are seen right here. It's going to be June 25th through July 24th. So this will give you one full month. Hold on a second. So that will be one full month worth of days. Now, yes, traditionally we start on the 1st and then on the 30th or 31st or 28th or 29th if it's of February. But given how this this semester is going, given how soon we are going to be finishing, not too long after the 24th, 25th, as you can see there, I just didn't want to make the project due like the same day of the final exam. I didn't think that would be very nice. So it was going to be impossible just to say, hey, let's just do all of July. So that's why we're going to split it up this way. Now you might say, well, why didn't you have us do all of June? I just don't think we were ready to talk about and deal with that issue at that point. We were still really kind of picking up the basics of Excel at that point, excuse me. And we're going to be creating a file on our own with no guidance, no video of me saying, hey, this is exactly what you do. You have to figure it out. I will tell you the things you need to do later today, but I'm not going to show you. You are responsible for figuring that out on your own. It's a project, not a regular homework. That's the difference. So you will need to be making your budget, and you're going to be doing this in Excel from the 25th of June to the 24th of July. And then you have to turn this in the very next day, the 25th, which I believe is a Sunday, the only time I'll have something due on a Sunday. And it's due by 11:59 p.m. And I'm having it due Sunday so that way I can turn it around and grade it by that class on Tuesday, hopefully, the 27th. Again, we're going to talk about many details of this, which you are actually responsible for later. But for now, let's go ahead and talk about the midterm. So the midterm is going to cover chapters 1 through 4. Chapters 1 through 4. And it doesn't feel like a midterm in terms of time because we're not going to finish chapter 4 for another week or so, which means the midterm is not going to be for about another 2 weeks roughly. So it feels almost like the 3/4 term. But in terms of material concepts, it is a midterm. But just know that the final will only be like 3 or so weeks after that. So when will the midterm be? Because I don't have a date on the screen, because I don't have an exact date on when we're going to finish 4.4 yet. So what I have up here instead is that the midterm will fall exactly 1 week after finishing section 4.4. That's the last section that will be covered in the midterm. I like to finish material and then have a midterm on it a week after. The final exam, it usually has to be the next class because we go until, well, the next to last class. So what's the midterm going to look like? It's going to be 20 to 25 questions, and it will be inside of my math lab. And I actually have this part wrong. I say a review will be provided in my math lab. That's not true. So the test, the midterm, is in my math lab, and a review will be provided. And you can see the next thing I say is the review will be in Canvas. So the test is in my math lab, and when it's available, because you don't see it yet, you're only going to see it for a couple of days. But when it's available, it will be the very top assignment in your assignments section. The review, however, will be in Canvas. It's going to be a PDF document that you can download, you can print, and it's going to be much longer. The test will be 20 or 25 questions, so either 4 or 5 points apiece. The review is going to be 50 some questions. It's either 50 or 60. It's in between 50 and 60. I know that much. I'm going to say it's closer to 60. So the review is much longer than the test because I'm not just going to give you a carbon copy of the test as a review. This is a quantitative reasoning class. I want to keep it a little more broad. However, the review will still help you narrow down and focus what you need to study. The test is going to feel much more like my math lab homework problems versus any kind of discussion board or any kind of Excel assignment. I'm not saying there won't be any questions on Excel in the midterm. There will be 1 or 2, but they'll be pretty simple in my opinion. But there's not going to be any part where you have to create an Excel file. There's not going to be any part where you have to write a sentence or a paragraph. It's going to be do some math, maybe a B, C, or D answer here and there, maybe a graph. But yeah, it's going to feel much more like homework. So again, the review is going to guide you and let you know what the test will feel like. Now, the review is not graded. Whether you do it or not, it will not affect your grade at all. But I do highly encourage you to do the review. I'm not making this for no reason. I'm making it available. So again, you have a better idea of what to study. I will also be providing a very, 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 very short, what I call formula sheet, although it doesn't really feel like a formula sheet because you're not going to see anything like how to calculate a periodic rate or how to calculate simple interest or how to calculate a weighted average. You're not going to see any of those formulas as I've promised all course. The formulas, the air quote formulas that will be on this sheet will be all about conversions, and it's just going to be a few of them. Now, remember, you're responsible for having everything to do with time memorized, 24 hours a day, 365 days a year, et cetera, 12 months in a year, 60 seconds in a minute, 60 minutes in an hour, all that good stuff. But what I don't expect you to memorize is that there's 2.54 centimeters to an inch, or that there's, oh wait, how many feet is in a mile? No, I don't need you to memorize that stuff. I will have that, whatever you would need in this little formula sheet. So if you needed one of those for the midterm, it will be in the formula sheet. That will be in Canvas. So there will be a section with the review and the Canvas that will all be in the same section of Canvas, and you will see that in the next week, roughly. I don't want to make it available yet since I just made the project details available in there, and I don't want to throw too much at you at once. Now, the midterm is not going to be taken during class unless you choose to take it during class. You will have 2 full days to take it anytime during those 2 full days, again, in my math lab. I will let you know what 2 days they are, again, very, very soon, just not today. And if you want to take it during our class time, then per usual, you can do so and then just catch the Zoom lecture on YouTube after the fact. But it's up to you whether you do it that way or not. You could also just attend class and then take the test whenever you have the time available. It will be 2 hours for the test. This is traditionally an hour and 15-minute test, but given the nature of everything, I'm giving you a little longer. You do need to show your work. Remember, quantitative reasoning requires work. So you should be writing your work down on a piece of paper or several pieces of paper, put your name on them, and then you'll take pictures or scan them and you'll upload them into Canvas within 15 minutes of finishing the test. Now, failure to submit work reserves me the right to give you a 0 on the midterm, and this is not something I want to do. So please understand that you are required to submit your work. No work, and I can take away your grade because I don't know if you actually did any of this or not. Remember, this is a no notes, no books, test, but you are allowed calculators. I encourage you to use calculators. Cell phones aren't calculators. You do need to use a traditional calculator, whether it's the one on your computer or a handheld one, but no cell phones. And again, you have to submit your work within 15 minutes of completing the midterm. So if I see that you finished the midterm at 12 p.m. and you submitted your work at 8 p.m., I'm going to think there's some shady stuff going on. And again, reserve the right to revoke your grade and give you a 0, something I don't want to do. The main reason besides that way you're submitting your work is maybe you get an answer wrong in my math lab on the test, but you had some good work. You had 3 or 4 correct steps and missed the 5th step or the 2nd step or whatever. Then you can email me and say, hey, Mr. Beckner, can you check out questions 3, 7, 9, and 21? I think I've got some solid work. You could even say in the email what you think you have right and wrong, if you choose to. And then I will go pull up your work in Canvas. I'll review it. I'll compare it to your work in my math lab. And usually I end up giving a decent amount of partial credit, and I'll respond to you and let you know. Give me 48 hours for reviewing your work with the midterm, though. It does take some time to go through everybody's once those emails start coming in. But please be proactive and shoot me those emails as soon as you can. If you don't hear from me in 2 days, then you can shoot me another email and say, hey, Mr. Beckner, what's the status on this? But I will get to it at some point sooner than later. So again, midterm, where is it? It's in my math lab. It'll be at the top of assignments on the 2 days that you have available. Do not miss the midterm. If you miss the midterm, you will need to submit some kind of paperwork to say why you missed the midterm, whether it's a medical reason or whatever. But I'm not just going to give someone a chance to make it up if they forgot to take it. There's no excuses for that in here. We got to be proactive and accomplish our goals. We got to do our work. 20 to 25 questions, 2 hours. Show your work, submit the work in Canvas. So the review and where you submit your work is in Canvas. The test itself is in my math lab. The review is comprehensive. You shouldn't see anything on the test that wasn't closely resembled on the review. And we will talk about the midterm a little bit more once those dates approach. But for now, we're going to go ahead and pick up where we left off with 3.4.
So we've done everything from chapter 3 except for density, and here we are. So density is a ratio. Oh my, a ratio? What is that? I've never seen a ratio before in my life. Well, that's just a bold-faced lie if you're in this class. Ratio, fraction. So density is a fraction. As I've said, everything from chapters 2, 3, and 4 on one level or another is some type of ratio. A lot of these ratios end up being proportions. We kind of extended the idea of proportions into things that we say we can't really do the fraction equals a fraction, but we can at least still relate them to each other. But another ratio, what is this the ratio of? It's not just apples to oranges, it's not students to teachers, it's specifically talking about an object's mass to its volume. Now, I want to kind of point out here that very often we'll actually use weight to volume. And you might be thinking, well, Mr. Beckner, weight and mass are the same thing. And that is not true, but it's also my point that most people feel like mass and weight are the same thing. Now, as long as we stay on planet Earth, your mass would have a direct correlation to your weight, and it would be consistent no matter what part of Earth you're on. But if we go to another planet, your mass would actually stay the same, but your weight would change because weight is affected by the gravitational constant of the planet you're on. For instance, Earth is 9.8 meters per second squared. Now you might go, meters per second squared, aren't things usually in meters per second? Good observation. Meters per second is a speed. Meters per second squared is an acceleration. So that gravitational force value, that constant of 9.8 meters per second squared, is not a speed, it's an acceleration. Now, we don't have to worry about what that means. That's not the point of this. I'm just trying to say that that number, that 9.8, if you go to the moon, it's lower. If you go to Mars, it's kind of in between Earth and the moon. If you went to Saturn, it would be much larger. If you were ridiculously close to the sun, it would be in the thousands or tens of thousands or millions, or I don't even honestly know, because I'm not trying to go stand too close to the sun. I'm not Icarus. So again, while your mass and your weight are technically two different values, with two different types of units, and one of them is affected by the planet you're on, we kind of use them interchangeably. So when you're in England and you say, oh, I weigh 100 kilograms, that's a mass. But when you're in America and you say that I weigh 220 pounds, that's a weight. So the American system is a weight, but the non-American system, the thing that everybody else uses, is a mass. So that is the reason that I feel like most people find these two to be interchangeable. And you're probably not ever going to leave planet Earth in your lifetime. Notice I said probably. I can't make giant assumptions, but statistically it's probably true. So you're gonna be like, well, mass and weight are the same thing to me. In fact, one country uses mass and another country uses weight. So why aren't they interchangeable? So again, if you're gonna be in a science class, I would not be doing this, but in a QR class for just a concept of a ratio of something that measures your mass or weight to your volume, which is the amount of space you take up, or an object. It doesn't have to be you yourself. So that's just the ratio. So if they give you a measurement in feet or inches or miles, not cubic units like cubic feet, cubic inches, cubic miles, which is volume is always measured in, you're going to have to convert them. Now, this is pretty rare in most instances in the real world. If I give you some oddly shaped object, I would probably have to tell you what its volume is because you're not going to know the formula to find the volume of that shape. But in our class, I can say, oh, here's a cube or here's a box with these three dimensions, and then you could find the volume by just using an appropriate formula. So I will admit this is not super necessary unless you're going between cubic inches to cubic feet if they ask for a change like that. But I still want to remind us of the way we convert things that way. You can cube both sides of the conversion factor, or you can also just multiply by the same factor 3 times, as we saw in 3.1. So again, not really going to focus on this issue here, although you'll think we are because you see this thing just says 2 feet. It doesn't say 2 cubic feet. And that's because it's what I alluded to earlier. We're only measuring one side, and it is a cube. Okay. So let's get to the example. A box of supplies weighs 42 pounds. So we've got some box, and hold on, that pen's being weird. We got some box, leave a little space for the actual problem. Here's our box. Now, I'm going to assume this is a cubic box because it says if the box has equal dimensions on all sides. Now you might be like, Mr. Beckner, that doesn't look like a cube. Please ignore my poor artistic ability. It's a cube. So this box weighs 42 pounds in total. The whole thing is 42 pounds. So if you put that box on a scale, it comes out to 42 pounds exactly. Now this box has equal dimensions, and we get out our measuring tape and we measured one side to be 2 feet. So if you go from end to end, so again from here to here, that height would be 2 feet. Or you could go from end to end horizontally, and this width would be 2 feet from end to end. Or if you measured this distance right here, this distance would also be 2 feet. So it's 2 feet by 2 feet by 2 feet. And I know this doesn't look like 2 in comparison to this, and that's because we're looking at this box mostly from a forward perspective. So we're just barely peeking around the corner to see that it's an actual 3-dimensional shape here. All right, so the box has equal dimensions, and they say, what is the density of the box? And I say, note, you still need to convert your units, but it's not going to feel like a conversion problem. It's just going to feel like finding a volume, because the density is the ratio of mass to volume or weight to volume. We're going to use weight. Again, this is not technically true, but good enough for a QR sake. So again, I said you have to convert your units, but that's just because we got to find the volume based on the fact that it's a 2 by 2 by 2 box. So the first thing we're going to do is find the volume, which is 2 feet times 2 feet times 2 feet. How do I know that? Because the volume of a cube is length times width times height. That is a geometric formula I do expect you to know. The volume of a box is length times width times height. I'm not going to ask you to memorize the volume of a sphere or a cone or a three-dimensional triangle or any kind of, or pyramid. I don't know why I said triangle. Pyramid. I'm not going to ask you to memorize any of those goofy shapes, but you do need to understand the basic concept of two-dimensional and three-dimensional shapes. Area for a rectangle is length times width. Volume for a box, length times width times height. Now check this out. The 2 times 2 times 2 is 8. And some person might say this is 8 feet, and it's wrong, because you have feet times feet times feet, which is feet cubed. It's like having 3 times 3 times 3 is 3 cubed, or x times x times x is x cubed. So that's it. There's our volume. So how do we find the density? The density is just the ratio of mass or weight, whichever you're given. Again, technically it's only mass, but in here we can use weight as we're about to do. So how do I know which way to divide them? Do I do weight divided by volume, or do I do volume divided by weight? The formula says the volume goes on the bottom. If you do these backwards, it's wrong. Volume must go on the bottom. So the 8 feet cubed, or 8 cubic feet, must go on the bottom. And the weight, which we said was 42 pounds, or the mass if we had it in, say, kilograms, was the 42 pounds. Again, like I said, it's very interesting because pounds is a weight, but kilograms is a mass. Your mass in kilograms is the same on the moon, is the same on Jupiter, is the same on Mars, is the same on Earth, but your weight in pounds would be different because they take into account the gravity. I know it's weird, just go with it. So we do 42 divided by 8, and let's see how, if we have to round it all. Spoilers, we won't. We get 5.25. So 5.25 is the answer, right? Maybe if we're not a quantitative reasoning student, no. As a quantitative reasoning student, that's wrong. 5.25 what? 5.25 oranges, 5.25 bobs, 5.25 oranges per bob? No, it's 5.2, that's an ugly 2, isn't it? 5 pounds per cubic foot. Or you could write with the word 5.25 lbs per cubic foot. Hello. That looks like a 2, but it's a 3. I had some gunk on my tablet, apparently. So there's our answer. Again, either of these is perfectly fine. Both mean the same thing, whether you write the units in fraction form or with a per form. So what does this mean? What is the point of this problem? What's the uniqueness of finding a density, or what's the reasoning to find a density? I don't know why I said uniqueness. Let's say this box was filled of just one object. It's filled with a bunch of marbles or something like that, or a bunch of sand, or I don't know, a bunch of very hollow beads, whatever. So this box is filled to the brim with the substance, and you go, well, I just hurt my back, so I don't really want to carry 42 pounds right now. But this is 2 by 2 by 2. What if I were to maybe slice this box? So I'm going to slice this box like so. Be careful this way. So that each of these little red boxes is 1 foot by 1 foot by 1 foot. So again, this right here, each of these, oops, I got a little crazy on that one, didn't I? Just trying to emphasize, this little cube right here, which of course has, if you wanted to see through the cube, there's the whole thing. That's a 1 by 1 by 1, and there would be 8 of these. There's 1 here, 2, 3, 4 in the face, and then on the back side, there's 1, 2, and then 3, and then 4 behind it. So there would be 8 of these little 1 by 1s. 1 by 1 by 1. And each would have 5.25 pounds in it. That's what you can do with the concept of a density. You can break this down into smaller things. Now, do you have little 1 by 1 by 1 boxes? Because you certainly can't just take an open box and go from a 2 by 2 by 2 to a 1 by 1 to 8 of these 1 by 1 by 1s. You'd have to have 8 1 by 1 by 1 boxes. But again, let's say 42 pounds is too much for you to handle with your back and this, bigger, more awkward 2 by 2 by 2 box. So you go, all right, well, let me instead buy 8 smaller boxes, fill them up with this equally distributed object. And then you'll have 8 boxes with 5.25 pounds. And if you took 8 times 5.25, guess what you get? 42 pounds. That kind of goes in line with that concentration idea that whether you have one box with 42 pounds that's 2 by 2 by 2, or 8 boxes that are 1 by 1 by 1, 5.25 pounds in each, you still have the total amount of the thing at the end of the day. Now, if you're filling these boxes with DVDs and weights and water jugs and things that are not equally distributed, you'd have a much harder time doing this equally, but you could at least still say, let me go get 8 boxes and just try and put about 5 pounds in each. And then everything would be, again, much easier to carry on your poor old back or young back. Maybe you had an accident, I don't know, lifting too much weight at the gym from all that protein powder from a chapter ago. So densities of objects in the real world are not always equally distributed, like I said. If you have a box full of beads or sand or something like that, it's all the same thing and it's filled to the top, then that's an equal distribution of weight most likely. But if you've got a box with a 10-pound dumbbell in it and a calculator in it, you're not going to be able to equally distribute those weights if you try and put it in 2 boxes, one box with the 10-pound dumbbell and one with the, what did I say, a calculator, I think? Obviously, the calculator box is going to be lighter because those weights don't have the same densities. Think about it like a balloon versus a bowling ball. You could have a balloon the size of a bowling ball, but the bowling ball is a lot denser. The material inside of it is heavier. So even though they're the same size, they have different densities because their sizes, while the same, their weights or masses are different. So the bowling ball is denser, whereas that balloon is very, very, very not dense. All right. So with that said, that will close out chapter 3.
Just give me a second. I'm setting up for our project discussion.
Right. So I want to take a solid amount of time and talk about our project. Now, I know this is project 1. It could be our only project. It could be one of multiple projects. It just depends how the course is going. And I would have said this to you. You will find your due date in the intro of a live lecture, as well as in Canvas, and the Canvas due date will be the whole time. This talk is just to keep things a little more generic for my various classes, since I teach this more than once each semester. So let's see what we got here. Each student is responsible for creating a monthly budget of all of their expenses for the month of, and just a couple words I might have to take out for the month assigned. Now, it does not have to be a specific month. Now, you notice that I had November written there. So once in the past, it was the month of November. I've done the month of February. I've done the month of June. I've done split months, like say January 16th to February 15th, or December 20th through January 19th, something like that. So that will also be something that is detailed in Canvas and in the intro. You'll find this file in Canvas where it will have your exact dates. So Each student is responsible for creating a monthly budget of all their expenses for the month assigned. And again, it doesn't have to be just a February, it could be a split month, like we said, March 15th to April 14th, something like that, maybe. If you do not spend money regularly, you need to ask your parents or your spouse or whoever you have close to you who is basically giving you the financial assist what they are spending on you each day. Now, some parents or spouses or brothers or whatever might consider this to be nosy and they don't want to tell you these numbers, and that's the lifestyle that they choose to live. I would love for all of us to be in a society where we can openly talk about our finances a little more, but I'm also not going to tell anybody what to actually do with their lives, as you already know. So, besides do your homework, that's what I will tell you. So if you are in a situation where someone does not want to tell you what they're spending on you, then you can see I have in all caps the sentence after that. Just make up your own numbers if absolutely necessary. Um, I'm not going to be grading this based on, oh, you spent too much on video games this month, or you spent too much on your car, or you spent too much on this, or too much on that, or too much on this, or you didn't spend enough on this. That's not what the grade is going to be about. The grade will have absolutely nothing to do with the expenses. The grade will be based around, did you do the 6 things that I asked for that we'll slowly go over? Did you use Excel formulas appropriately? Did all of the calculations, add out correct, multiply out correct, whatever operations they're supposed to be doing? Did you make your charts? Did you make an analysis? That's what you're going to be graded on. I don't care if I have student A who has $10,000 worth of expenses in a month and student B who's got $10 worth of expenses in a month. That's not what's being graded on. Again, it's, did you actually do this task? What the purpose of this is for you to have something that you can use the next month and the next month and the next month and the next month to keep a good record for yourself, to understand where your money is going and where it's coming from each and every month, as well as to I don't want to say introduce the idea of prorated expenses, but to kind of get you used to them as well. So again, this is not going to be graded on the fact that oh man, you only bought 7 things this month, or you bought 200 things this month. That's not what's graded on, although I do have some minimums, as we'll see. Rows should be the days of your month. Columns should be your different categories. The furthest right column should be your total daily expense. Now remember, rows are horizontal, columns are vertical. You have to get this right. Every semester I get maybe 1, maybe 2 students who get this wrong, and you get punished in the point department because of that. So row 1, row 2, row 3, row 4, row 5, row 6, column A, column B, column C, column D. So again, what we've said, let me just kind of shrink this so we can see a little bit of everything. Shorter, there we go. Rows should be the days of your month. Row 1, row 2, row 3, you can see those. Columns should be your different categories. Column A, column B, column C, column D. So if your project was supposed to start on, say, December 1st and end on December 31st, which I would never have done because that would be over a break for standard semesters, but let's just say that would be the case, then you're probably not going to start in this block because you're going to have a column of labels and a row of labels for these things. So actual data doesn't really, like numbers and things, won't get put into until you get into like this section and further right and further down, of course. But again, you must have your rows and columns labeled appropriately. If they are flip-flopped, you will be penalized for that. And it won't be a small penalty either, because, I mean, this is 2 of 6 issues of the whole thing. So I could arguably take up to about 20 points for that. Okay, if you have more than 19 categories. So what's a category? Well, a category is what you decide to call it. I'm not going to say that everyone has to have a category called rent. I'm not going to say that everybody has to have a category called mortgage, because some of you have rents and some of you have mortgages. You could just, call it roof if you want to. I'm not going to sit here and analyze the name of the category just to make sure that you have something that represents, well, you should be paying for, quote, roof somewhere, probably, unless you've inherited a house. And if you have, you still have your taxes and insurance. So you could, still call that, quote, roof or rent or mortgage or house payment or whatever you like. So if you have more than 19 categories, because some of us have lots of various expenses, and especially if you decide to have a category for fast food, a category for dining out, a category for grocery bills, another person might just have one category and call the whole thing food and lump all three of those together. Some of you might just have a category for groceries and then another category for all other eating. So eating at McDonald's or eating at Olive Garden or eating at I don't know. I was gonna try and think of some nice little local spot, but it doesn't really matter. So again, one student might have three different categories of food. Another student might have two categories of food. Another student might have just one category of food. But everyone better have a category of food because we all got to eat, and food is not free. All right. So if you end up with more than 19 categories, I don't need you to go into 20, 30, 40 different categories because then your Excel spreadsheet is going to get really, really wide. So just call the last one, the 20th one, miscellaneous, and then lump everything else into that. And again, I don't necessarily care how you're dividing this out. I don't care if the food category is before the rent category or vice versa. It's just if you end up needing more than 19 categories, call the 20th one miscellaneous, and then just lump everything in there. Whenever you have a miscellaneous expense, if you could, to the right of that total daily expense, you could just make a little memo and say, hey, this miscellaneous expense was for, I don't know, paper clips, or this miscellaneous expense was for a calculator. I don't know. Some of you, I would say probably half of you maybe won't even have this miscellaneous category because you'll only have 10 or 12. Please note that I say there is a minimum of 6 categories. If you do any less than 6 categories, that's when I start to take away points from your grade. Now you might be saying, Mr. Beckner, I only paid for 3 things this whole month. So make it up then. Again, if you can't meet these minimums or you can't get the information from someone, then just make it up. But understand that in your life, you will be paying for this stuff eventually. So have this sitting to the side, ready to go once you can start building your own expenses and your own budget. So made up numbers are okay for now, but just know that you should try and use this in a real fashion at some point. And by the way, if I haven't already made this clear, I do not care what your numbers are at all. When I go to grade these, I have a method to grade them completely randomly as long as you don't stick your name inside of the Excel file in a cell somewhere. So I'm not going to be sitting here judging you for your expenses or anything like that. Your grades will 100% be based off of completely anonymous information. And again, I'm not going to sit here and go, oh, well, yeah, Alex is spending $400 on this product and Jane is spending $1,000 on that product. And look at Bob, he's spending $100 on lotto tickets every month. Get out of here, Bob. No, that's not what I'm doing. Again, I have no judgment here at all. We are all in different financial positions, and I really do not care about your expense portfolio, your monthly budget, any of that stuff. I just want you to use this for your personal growth. And when you're done with this course, months from now, years from now, if you don't want to use this exact format of an Excel spreadsheet for your budget, go online and find a website that has something that could be helpful. There are a bunch of different budgeting websites out there, and I'm not going to advertise for any of them at this moment, but I'm pretty sure Google could find you one pretty easily, 1 or 2 or 3 or 4. So again, for the categories, you can combine some things. We've kind of talked about that food. You can expand some things. It's up to you how specific or non-specific you want to be, as long as you have at least 6 categories. Now, categories can be lots of different things besides food and rent. You have medical expenses. You have vehicle expenses. You could break down the vehicle expenses into multiple categories. You have insurances. I said medical stuff already. You have textbooks you have to buy. You've got courses you have to pay for, clothing, food, investments, if you wanted to call that an expense, because it would be paying off a loan, paying off your credit card. You could be a category as well. Okay, so hopefully that clarifies that. Now, if your expenses vary wildly from month to month, which if they don't now, they will at some point in your life, especially if you own a home. Medical expenses, you break a leg, all of a sudden you got a couple $1,000s to pay. You need some fancy surgery, even with insurance, $10,000. So that would be a case of something varying wildly. If you own your own home and you got a really bad leak and you get the inspector out and it turns out he goes, well, this roof is 29 years old and it's seen about 15 hurricanes, it's time to replace this. And then that's, $6,000, 10 grand, 15 grand, depending on your home, depending on whether you're doing the construction or hiring it out, that kind of stuff. So yeah, your January you might spend $1,000. Your February you might spend $1,200. Your March you might spend $800. But then April, that roof bill comes in, and your $1,000 monthly bill is now like $1,100 because you got 10 grand on top of that. You might say, well, Mr. Beckner, I'm getting a loan for that. So, that's not going to be technically an expense. Then I just add in that loan payment. Sure, but you could also maybe have saved cash away because these big expenses come up eventually, and then you're able to just conveniently slap 10 grand down on the table, get your new roof, and no loan, no paying 3 or 5 or 10% APR monthly payments for 5 years, 10 years, who knows. And then by the time you get that loan paid down, it's time to slap another roof on the house. Who knows? So what is the point of this rant? So if your expenses vary wildly from month to month, consider every possible expense you have. Things like your car insurance, your taxes, your doctor's visits, your prescriptions, your house repairs, car repairs that could be done in quarterly or annually or semi-annually or all sorts of different installments. So car insurance, a lot of people pay this twice a year because if they pay it monthly, they have to pay just a little more. There's basically a premium bump. But if you pay it semi-annually, which means every 6 months or twice per year, then they might save you like $30 or $40, and in the long run, that can be worth it. All right, so if your car insurance comes in January and July, that means you might have like a $400 bill in January, but then nothing February, March, April, May, or June. So it seems like your January expenses are significantly higher, but that's because you're paying this big lump sum in January that's going to cover you for February, March, April, May, June. So let me give a simpler example. Let's say that your car insurance was pretty cheap and it was $360 a month. At least that's cheap relative to someone in their mid 30s and male and doesn't have a horrible track record on the road. Someone else, maybe $720 is cheap. But let's just say you paid $360 for 6 months worth of car insurance. So if you take that $360 and divide it by the number of months it's covered for, so you're doing dollars divided by months, you would get a value per month. It's a simple rate like we talked about in chapter 3. So 360 divided by 6 would be 60. So your $360 you pay in January that covers you through January, February, March, April, May, June, in reality is much more like a $60 expense January, a $60 expense February, a $60 expense March, and 60 in April, 60 in May, and 60 in June. You just have to front the cost. So for myself, if I were the student doing this monthly budget and I have my own monthly budgets and this is exactly how I do it, I would not say that I paid $360 in January. I would say I paid $60 in January. And then in my February budget, I would have that $60 allocated. In March, I would have that $60 allocated, and I would have, quote, prorated car insurance. Now, again, in reality, when that bill comes, yes, I'm $360 broker in January and then again in July, but we set that cash aside throughout the previous 5 months. That way, when we're ready to pay it, it doesn't feel like it's a big deal. And then over the next 5 months, we build that $360 back up so that we can pay the $360 again in July. And then through July and then July through December, we save another $360 to pay it in January. Vehicles, staying in this realm, okay, you drive your car for 5 years, 10 years, whatever. All of a sudden, you need a new timing belt or timing chain after 100,000 miles or whatever your vehicle might require. And they go, oh, okay, well, if you're going to do the timing belt, we might as well do the water pump while we're in here for most cars. and all of a sudden you've got a $1,000 or $1,500 vehicle expense. And you go, oh no, well, I wasn't expecting this. What do I do? Well, you consider the fact that you know your car is going to cost you a lot of money at some point. So just like that insurance, you're setting aside maybe $100 a month or $150 a month. And you won't be able to guess this exact number without life experience and being used to the same car. But with practice and manipulation, you can get this whittled down better. So, oh, okay, I'm going to put $100 away a month, $100 away, $100 away, $100 away. Now this is for oil changes and tires and random breakdowns and whatever. So after 3 years of me storing away $100 or you storing away $100, now some of that money's been taken out for oil changes and tires and inspections and whatnot. But then hopefully when it's time to replace that timing belt and water pump and whatever else they're going to fiddle around with, you've got that $1,500 sitting in the bank because you consider these prorated style expenses. And you can say, oh, well, I don't necessarily, yeah, I have this $1,500 expense in the month of March, but in my monthly budget, I've been setting aside 100 or 150 or 80 or however many dollars. So that's what I'm talking about if your expenses vary wildly. Now, some of us, this is not an issue, so don't worry about it. But again, just know that in your future, this is likely to be you as well. Now I orally talked about taking a semi-annual car insurance and turning it into monthly. Here you have a vehicle property tax of $240 per year. Now there's 12 months in a year, so you divide by 12, so that gives you $20 per month as a rate. So vehicle property tax is another thing that comes in typically once per year. You're not paying your vehicle property tax monthly unless you're in some weird situation that I have not seen before. If you outright own your own home, you're not making a mortgage payment, which I know is not a lot of people out there, but your taxes come quarterly or every other month or semi-annually, depending on the city. Your insurance bill comes annually. So these are other expenses that you might want to prorate. So I've said that this idea of prorating your expenses is not mandatory, but it is highly recommended for your personal life to consider things like that. So again, prorated expenses, a very, very important concept moving forward in your life, especially for the idea of storing away some acorns for a rainy, cold winter day or something like that. Now, I do say that I need you to list at least one prorated expense in your budget or lose 20 points. I used to actually do an entirely second part of this project, which people messed up more than actually got it right, unfortunately. So I've kind of axed that and just said, all right, you have to put at least one prorated expense in there, and please make sure that I know which one it is. So have a little memo somewhere. It says, hey, this expense on March 1st, or this expense on January 1st, or this expense on August 15th was my prorated expense. So that is a significant point loss if you don't do it. Now, once again, if you don't have any of these expenses, if you are living off of someone else and they won't tell you these numbers, they won't tell you how much your rent is, your portion of rent, what it would be if you were paying it, or how much your gas bill is, or your electric bill, or water bill, or trash bill, or anything like that, just make it up. I don't care. I'm not going to call up your parents and say, did Bob actually spend $25 this month on blah, blah, blah? You can completely lie to me about every single number. Again, that's not what I'm grading you on. All right, so I did mention earlier, I want to pop back up here with the rows and the columns. The rows should be the days of the month, and please make sure the month and the day are labeled. Remember that there are quick ways in Excel to make that progress without having to type out 30 or 31 of those. You just have to do one or maybe two, and then you can use a fill handle probably, depending on how you format things. But I said that the furthest right column should be your total daily expense. So this is another thing, if you miss it, that's significant points lost. So maybe on January 1st, you spent $5 at the corner store, and then you spent $20 on groceries. So there in that total column on the far right column, it should say $25. Now, it shouldn't say $25 because you literally typed 25 there. Remember, total columns in Excel are meant to be used with formulas. You should only have to type one formula for that column and you should be able to fill it down. If you don't do that, you will lose 100% of the points for that total column. So if you're typing a different formula for each row, if you type a formula for January 2nd, and then you type a formula for January 3rd, and then you type a formula for January 4th, that's wrong, 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 wrong. You should have only had, if your month was January, you should have only had to type a formula for the month of January, or sorry, for January 1st, and then just fill it down for the rest of January. Easy as that. Just like we emphasized with the Excel homework. So here's something I need you to understand with that. I might go in your Excel file and completely change your numbers, and I'll say, nah, Bob didn't spend $20 on groceries that day. He spent $25 on this other category. And I'm going to watch your total column and see if it changes. And if it doesn't, then you're in trouble. Or I can just, double click on your formulas and see what they have, and I can instantly tell whether it's right or wrong. But I just need you to understand that. This is supposed to be set up for super easy future use. So when you use this for the next month and the next month and the next month, you just put in, oh, on February 15th, I had $15 of groceries. On February 16th, I spent $40 on my cell phone bill. And then all those totals just change with the snap of a finger. All right. So we said the last column should be a total of daily expenses. Down here on spot number 4, which means number 3 was this. I don't know why that changed. 1, 2, yeah, there we go. 3. So here we are at 4. Your last row should be the sum of each category. The last row should be the sum of each category. So this means I want to see what your monthly expenses are for your groceries. I want to see what your monthly expenses are for your fast food, or I want to see what your monthly car expenses are, however you're labeling your categories. So that way, if you went to the grocery store 5 times, on this very last row, you can see how much you spent on groceries that month. Or if you have a column for fast food and you hit up Chick-fil-A, let's say 23 times, you're going to see how much you spent on Chick-fil-A or all your fast food altogether. And then some of these numbers might scare you a little, and that's half of the point of this. Because these small expenses that you might do every day add up. So you'll have a total column and you'll have a total row. The column would be the sum of the days. The total row would be the sum of a category. Next, I want you to create a pie chart, big fan of this for budgets, that will include every expense category with the exception of the sum of daily expenses. We've talked about with pie charts why you don't want to have the regular categories and then a sum category. This was very early in the semester. So your pie chart should just be based on the categories, using the totals from part 4. So in other words, you will create your pie chart based off of the last row, which is the sum of each category. So your pie chart is only based off of a single row, the last row, and it's the sum of each category. So that way you'll have a slice for groceries, you'll have a slice for cell phone bill, you have a slice for rent, you'll have a slice for, again, however you're labeling your categories. Now remember, with pie charts, the idea here is that pie charts give you a visual representation of percents. So when you're labeling your pie charts, when you go through that labeling process, make sure they are labeled as as percentages. So in the pie chart, I don't want to see that you spent $1,200 on your rent. I want to see that your rent was 31% of your expenses. I also need to make sure, you need to make sure that your charts are well labeled. So when you have your pie chart, if they just say category 1, 2, 3, 4, 5, nope, you're going to lose points for that. It should have, all right, the red one is food, the green one is your rent, the blue one is your car expenses, the orange one is your medical expense. Not those specific colors, the specific categories. You get the point, I hope. So this is the bulk of your work. You got to have your specific days of the month, or months if we split the month, labeled. You've got to have at least 6 categories, You need to have a column for your totals for each day. You need to have a row for the total of each category. You need a pie chart based on that total for each category, labeled appropriately. And then the very last thing we have you do is a quick analysis. And this analysis can go anywhere in the Excel chart. Keep it in the main section of the screen. Just find one cell, click there, and type a sentence, a paragraph, whatever. Please don't just type 2 or 3 words. I at least need a sentence. A paragraph would be cool, but a sentence or 2 is perfectly fine. So make an analysis of your monthly expenses. So this could be you saying, I think I'm putting enough away to my investments or my savings account, or I think I'm spending too much on my Carrera GT or whatever. Maybe I need to spend less on my rent, or maybe I need to spend less on fast food, or maybe I need to spend a little bit more on this category because my clothes are ratty or something. I don't know. Now, I don't need to know any kind of checking account or savings account numbers. This is not a budget where you're starting out with, oh, I've got $500 in my checking account and adding and subtracting that. No, this is just showing you what you've spent in a month. So this is not necessarily having to do with incomes. Now, outside of this course, could you modify it to do that? Yes, absolutely. That would be a great idea to modify that. And then, so you make your spreadsheet and say it took up all this space, and then let's say this was January, and then you say, all right, well, now I want to do this for February. So you use the plus sign, you go back to sheet one, you can copy all the information there, paste it here, and all you'd really have to do is change your days and months and maybe your categories, I don't know, delete the old numbers and put your new numbers in. And then that total column should still be adding everything up correctly. Your total row should be still adding up everything correctly, and everything will be fine. And then you can go to March, and then April, and then May, and then June. And I've had students say, well, that's annoying to have to keep copying and pasting. That's less annoying than starting the whole thing over, I'd say. So again, what I really like about this project is that it's going to get you to become aware of what you're spending every month, because I find that most people are not aware of this. And that could enable you to say, oh, well, maybe I'm spending too much on this one category. Like, I will even spoil this one that's very common is, man, if I spend a little more on groceries and cooking at home and a little less on dining out or fast food or Starbucks coffee or anything like that, maybe I could take that money and put it somewhere else, like a savings account or an investment account, or put it towards a future car or a future, anything. Because as we will see in these later chapters, when we really start talking about compound interest, small savings each day, each month, each year over a long period of time, when invested, can turn us into a millionaire with enough time, effort, and knowledge. So that little $3 you might be saving yourself a day, if you can do that for 50 years, you can make bank off of that as long as you're doing the right thing with it. You're not sticking it in a CD, or you're not just leaving it in a 0.01% interest rate checking account, something like that. Okay. Oops, wrong thing. That's not what I wanted. Ignore that. So you will be submitting this in Canvas. You also find the downloadable file that we were just looking at in Canvas. So when you log into your Canvas shell, I'm in the student view right now, you'll see about halfway down under your quizzes and everything, there's that project category. And if this is not available yet, just give it one more day and it should be available. And obviously yours will not say fall 2020, that is the past. I'm just using this as a visual example, but you'll see two main spots in the project. You'll see one spot for the actual file to download. So if I click this, it would take me to the page where I'll see that and be able to download it. And it would be this, except it would have your actual due date here. It will have the specific month that you're going to be working on here. So those details will be seen in the downloadable file of Canvas. Under that link, you will see the link to submit your project here. Now this has to be an Excel file. It cannot be any other fancy spreadsheet file. As we've talked about all semester long, it does need to be an Excel file. This is not auto-graded. I will have to go in and grade these, so it'll probably be a week and a half before I get to these, because I get a lot of projects all at once and they are time-consuming to grade. So please be patient with me in that regard. But that's where you'll submit it. So you'd click there. And then you hit the button that says submit assignment, and then it'll take you to a screen where you can just upload your file. It's pretty clear. And then the due date, it's back, not gonna work. Back didn't work. Da, 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 da. And then again, your due date, it would be seen here, just so you know. And again, I will always say those due dates at the start of live classes. They can be found inside of Canvas. So hopefully that's not too confusing. Okay, so last time through this really quickly. You'll make a monthly budget. You'll have your rows be the days of your month, columns be the different categories. If your rows just say 1, 2, 3, 4, 5, not good enough. Need slightly more detail than just 1, 2, 3, 4, 5. Columns are your categories. How many categories do you need? At least 6. How do you break them up? However you like. What do you do if you have no expenses? Make them up. What do you do if you're trying to get your parents to tell you your expenses, but they won't? Make them up. If you go online, I'm sure you can find rent prices, home prices, things like that, monthly payments, whether it's $1,000 for this apartment or $1,500 for this house. That could help you get a ballpark idea. Now, let's say you live in a house of 4 people and the rent is $1,600 a month. What you could do is you could prorate that to yourself. So you could say, all right, it's $1,600 a month for 4 people. That means my quote portion of the rent would be $400, 1,600 divided by 4. So you could do something like that. Again, if you're a kid or a brother or spouse or sister in a situation where you're not earning income, and again, someone doesn't want to actually tell you the numbers. We said that I would love for you to try and prorate some of your expenses, but I did say you must list at least one prorated expense and mention somewhere in the Excel file which one it is. That's a significant point loss if you don't. You have to have your sum column, which is the sum of the days. You have to have your sum row, which is the sum of categories. You have to make your pie chart. That has to be listed as percentages, not dollar values. That chart has to be labeled, not just 1, 2, 3, 4. It has to be labeled rent, food, car, health, whatever. And then somewhere you have to just make a sentence to paragraph analysis of your monthly expenses. I'm not going to take away points if I disagree with your analysis. I'm just going to say, hey, did they write a sentence or a paragraph? Did they actually look at the information they have? All right, cool, full credit. That should be the easiest of these 6 sections to get complete. So again, you'll find your due dates in Canvas. Typically, this is about 5 to 6 weeks after it being assigned. So just please understand that. If we're live, like I said, I will tell you those due dates at the beginning and or end of the class if I don't mention it right now. And if you have any questions, you can always email me about this, but I think everything should be pretty clear and concise. Make sure this is your own work. Make sure you are starting with a fresh Excel file. Do not go to the internet and try and download something and copy paste it. Things will look weird. I'm not grading on like colors and bolding and shading and borders or anything like that. So, gonna put some numbers up here. So Bob turns in his Excel file and he's got everything labeled up here. Everything looks good. And it's just that the whole point here is just the numbers are not bolded, they're not accentuated, they're not colored or anything like that. That's not what I'm grading on. Bob would get 100 if all the formulas are correct, everything's labeled appropriately, they've met the minimum standards. Okay, so Jane does this. Jane has different numbers, but I don't feel like changing them. But Jane decides that she wants everything gridded like this. Okay, I don't care. I'm not grading on that. And then maybe Alex comes in and he decides that he wants this column to be orange, and then he wants this column to be yellow, and he wants this column to be green. Again, I'm not going to be grading on that. You're not being graded on anything having to do with color, outlining, bolding, shading, none of that stuff. You're graded on all the details I have talked about on that sheet. And again, you can download this sheet from Canvas. So hopefully we all understand what is necessary. All right, so that will be the end of the project discussion.
Sorry about that pause. I was just setting up the next portion of the video where we're going to get into chapter 4. So we're going to start with 4.1, and we are not going to finish this section today, but we will make some decent progress.
Chapter 4, 4.1, percentages, something that we should all have a basic grasp of already because this is a prerequisite topic. But even with that in mind, I still want to make sure that we all remember how to convert between our percents and our decimals and our fractions, although admittedly, the last one is seen less often. So a percent is just another way of representing a decimal value number. Now, you might say, well, what about wholes? Well, a whole is a decimal value number. It's just you don't see the decimal. It's at the end of the number. So 4 is still a decimal. It's just 4 point. 4.0, 4.00, 4.000. Those would all be the same thing. Percent, the word percent, it starts with per, and we know what per means now. We've hammered that into our skulls by now, that per means the next thing goes in the bottom. And the word cent, think about in terms of money, 1 cent, it takes 100 of those things to make $1. So the word cent is, pun intended, centered around 100. So the word percent literally means per 100. So it's like you take something and you scale it to 100. It's scaling something to 100. That's the entire concept of percent. We like to think in terms of percents because it gives us a good breakdown of numbers. It makes it tangible quite often. And if you disagree, that means you just need to deal with them more and more and more, hundreds or thousands of times, because like with anything, it just takes practice and use to get used to something. All right, so that was weird. Converting between a decimal and a percent, it's all about moving a decimal place twice. It's always twice when you're going between decimals and percents. It's just a matter of whether you move it left or right. So some people go with the classic, all right, when you go from a decimal to a percent, you're going to memorize to move the decimal twice to the right. And then some people will say, all right, go with the classic, when you go from percent to decimal, that means move the decimal twice to the left. And they'll just memorize these two little facts, and that's good. But if I just gave you a giant percent test and I gave you 10 problems in a row that were decimals to percents, then 1 problem that was percent to decimal, and then 2 more that were decimal to percent, and then 5 more that were percent to decimal, and then I just start blending them all willy-nilly, I bet you've got a more, let me say this differently. I bet you've got a more increased chance of getting one of those wrong because of all the back and forth. If I just give you 100 decimal percents in a row, you're going to get it down. If I give you 100% of decimals, you're going to get it down. But it's the fact that you need to be able to do this on the fly without knowing which one's coming at you. So when you're in that situation, you're a little more likely to make careless errors and just, oh, I'm going to go twice to the right when you were really supposed to go left. So that's why I give you this awesome trick right here, that a percent value should always look bigger than the decimal equivalent. So in other words, when you're just looking at the number without the percent symbol, that should look bigger, and specifically it should look bigger by a factor of 100. So what I'm saying is, let's say you had an example and you were supposed to convert 0.117 to a percent. If you were supposed to convert 0.17 to a percent, let's say you did this. Let's say you did this. You took its decimal and you said, I'm going to move it twice to the left. And then you got 0.0017, and then you tossed your percent symbol in there. So I had 0.17 and I moved the decimal twice. I know it's always twice. It's never 3 or 4 or 5 times when you're doing this type of conversion. And I chose to move it left, and I'm rushing, so I think I got that right. I go to the next one, and I keep going. Well, hold on. What's this little memo say that we were just talking about? A percent should always look bigger than the decimal. Again, so if you're just looking at the number that was with the percent symbol, 0.0017 absolutely does not look bigger than 0.17. This looks smaller, which says we did the whole thing wrong, but that little highlighted self-check is there to save yourself so many times. I can't tell you how many times it saved me, because I'm doing these things. Sometimes I'm going decimals percent, sometimes I'm going percents to decimals, and I'm thinking and I'm writing and I'm talking, and it's just so easy to go in the wrong order, and without asking, does it make sense, and without paying attention, that's where mistakes are made. So, okay, I know I was supposed to move it twice, but moving it left made it look smaller, so let's make it move right so that it looks bigger. Now we don't need to write this decimal because it's a whole, so I'm not going to write it. And then there's our percent. And 17 looks bigger than 0.17. That highlighted memo, oops, too far, has saved me countless times, and believe me, it will do the same for you. And the same idea, let's say you started with the 17%, and you said, I'm going to convert this to a decimal, so I moved the decimal twice to the left or right, and I'm panicking. Oh no, what do I do? I'm just going to go right. Okay, so that's 2 filler zeros, so then I get 1700. But what did Mr. Beckner say? He said the percent number should always look bigger, and that's because you're scaling it to 100. You scale it to a bigger number, the number should look bigger. We went through a guided activity where we kind of emphasized that. Excuse me. 17 does not look bigger as a number with the percent versus 1700. So that says I went the wrong way. Put it in blue. So when I had that 17 for the percent, I was really supposed to go twice to the left, which gives me 0.17. Literally the same thing as before. The decimal looks smaller than the percent, or this percent looks bigger than the decimal. Whichever way you want to say it, whichever way you like. So those are the 2 most common types of conversions you'll be seeing in this class. Admittedly, you'll be converting percents to decimals most, but we will still see some decimal to percent conversions as well. This converting a fraction to a percent, all you got to do is divide the fraction out. You got calculators, so you don't even have to worry about long division. Just type A divided by B, and then move the decimal twice to the right. Well, why do you do this last part? Well, because after you divide the fraction, you'll have a decimal, and then you're just converting a decimal to a percent. So it's kind of a 2-parter. There is an alternative method to doing that in one step. I am not going to teach it. It's not that intuitive to most people. It's something we teach in our, or taught in our developmental math before. I don't know if we're still teaching it because I haven't taught that course yet. It just started this semester. Anyways, there are other methods per usual. There's always other methods. I teach things to the point where, well, we've learned enough, we got to move on, or, you know, it's just a little bit too much all at once. Okay. So converting a decimal to a fraction, this is really not going to happen in here. This one is really rare. But you would say the number of decimal places is how many zeros you need in the denominator. So in other words, if I had something like 0.015, there are 3 decimal places, which means in my denominator, I need 3 zeros with my 1. And then all you do is just write that number in the top. So 0015 just becomes 15. And then, of course, you would reduce. I'm not even going to finish that problem because it's not the point. But 5 would go into both of those. I'll say it. It would then become 3 over 200. I'm just not going to write it. So this is not new material. If this is new material, you need to go out on your own and do hundreds. 200, 300, 400 of these, however many you have to, until it's stuck in your head. If you're rusty with this, same thing. This is not what I'm here to teach you. I just spent 5-10 minutes working on it because I feel like it's a good reiteration. What we're here to teach you is how to use percents in word problems and concepts like finance, like gaining interest on an account or paying extra interest on an account, depending on whether you're borrowing or saving. Yeah, so that'll be what we're working on. So this is going to be one of our favorite setups for these percent style problems at first. Not talking about something called percent change, that's a whole different beast. Percent change and just regular percent problems, those are two different beasts that we will study extensively. So right here what I'm talking about is if I say, all right, 15% of 1,000 is what? Or 22 is what percent of 85? Something like that. Or a more contextual problem like Bob gets 1% APR on his savings account that accrues simple interest. How much interest will he gain after 1 year? Now, without actually saying it, I asked what is 1% of however much he invested. I don't think I said that amount, but again, I'd give you the amount in the problem, as we will see. Okay, so this equation right here is how we are going to be working with our percent problems. We're going to have a part, a whole, and a percent value. And this is another case of we will get 2 out of 3 in the problem. In a problem, in order to solve this, you'll have to be given 2 out of 3. You'll have to be given the part and the percent, or you'll have to be given the part and the whole, or you'll have to be given the whole and the percent. You'll have to be given 2 of those 3 things to find the 4th. Do you know why that is? Because this is a fraction equal to a fraction. This is a proportion. This is a proportion that we have actually done before. We have had a part to whole relationship before, and we have scaled it to 100. This is not actually anything new. We're just laying it out in a more formulaic manner. This is just comparing apples to oranges, aka a part to a whole, and then scaling it to 100. This is just scaling to 100. That's what makes something turn into a percent when you scale it to 100. We have talked about that many times over. What are we scaling to 100? We are scaling the whole to 100. So we're saying, all right, if you have 55 M&Ms, which you want to think of this thing as a percentage, if Bob comes in and eats 2 of them, what percent did he eat? Well, okay, you have 55 M&Ms, but to think about it as a percentage, you got to pretend like you had 100 M&Ms. So we got to turn the 55 into a 100 by scaling it proportionally. Now the part would be the 2, the amount of M&Ms, excuse me, that Bob ate. Now, when we're actually doing these problems contextually, some people have a difficult time figuring out which is the part and which is the whole. Usually the part is the smaller value, but it doesn't have to be. It doesn't actually have to be for every single problem in the world, especially when we start talking about percent increase and decrease, which is a little different. But if you think about the problem contextually, you should be able to figure out which one is the part and which one is the whole. You just got to say what makes up the entire thing and what would be part of the thing. But another clue that you can usually find in the phrasing is you'll see the word of somewhere. And anytime you see the word of, the thing that comes after it is the whole. So this is just something that I suggest you memorize, because if you have a hard time, really cluing out that context, then that would help you. So I would say 90% of problems, notice what I just did there, that means 9 out of 10, 90 out of 100, 90% of problems usually have the word of in there somewhere. It doesn't have to be in there, but you usually see it. So if you see the word of, you know the next thing is the whole, which is what the bottom should be. The percent always goes with the 100, the part always goes with the whole. We've talked about part-to-whole ratios before. Again, lots of taking several topics and just squishing them together into one big, kind of circle. Everything is related to each other. Now, if you had a developmental math class or an algebra 1 class or whatever, where they say, okay, the of means times, is means equals, what number means x, what percent means p, if you were taught that and you know how to apply it 100% of the time, see what I did there again, then I am absolutely okay with you handling your problems that way. Per usual, as long as you have a method that will get you a correct answer, and that method isn't pulling the answers off the internet. As long as you have a method that will always make it work, I don't care how you get it done. I'm just teaching you a method that relates to what we've been studying for all of chapter 2, all of chapter 3, and what we'll continue to study in chapter 4, proportions. So we're setting this up as a proportion. All right, so we're going to do several examples that I've just kind of made up. I mentioned that there's a quiz question in Canvas. I'm actually going to show you what the quiz question is for about 5 seconds. It's at the end of these examples. Then we're going to pull up our worksheets, and I'm going to show you page 156, which will be your guided activity to have done over the weekend, but I'm going to expand on it. So the guided activity only has 6 answers, but I'm going to make it so that every single one of you can and will have to come in there and answer it. So every single one of you will have to answer this discussion board. So I will explain that in a few of them. All right, so Bob, like every American earning money, oh, I want to make a joke. It's not even a rating thing, it's just a political thing, so I'm not going to say it. I bet you can think about what that joke is, though, but I'm not going to say it. Something about people paying taxes or not paying taxes. All right. Bob, like every American, most Americans, has to pay taxes, Social Security, etc. If Bob has 28% of his income withheld amongst those groupings, so when I say withheld, I'm talking about taxes, Social Security, your FICA, Medicare, all that stuff, whatever. Like, not FICA, that's credit score. What am I saying there? And he had $19,880, so about 20 grand withheld last year. So Uncle Sam took 20 grand from Bob. Bob's probably not happy about that, but there's some other things going on here, so let's not panic yet. What was his annual income? So first thing I want to say is the way your money is taxed is bracketed. So if you make up to a certain amount, then you pay 12% taxes. After that amount, you'll pay 22% taxes, but only on the money above what you've already been taxed on. I don't have those numbers off the top of my head, but let's say it was $10,000. So you pay 12% up to $10,000. But then every dollar you earn over $10,000 up till, say, maybe 50, you pay 22%. And then after that, you pay 24%, then it's like 30%. But it's not like the first $10,000 you pay 12%, all of a sudden now gets taxed at 22%. It's just the extra income you make that gets taxed at 22%. I've heard many, many people go, I don't want this pay raise or I don't want this bonus because it's going to bump me into the next tax bracket and it will actually make me earn less money. That is completely wrong. It is completely false. And the misconception there is that they believe from going from, say, a 12% to a 22% bracket, now they're paying 22% taxes on every dollar they've earned, which is wrong. They're paying 12% on the first 10 grand, and then they'll be paying 22% on any dollar from 10 grand up to 50 grand. And again, all of these are rounded, estimated numbers off the top of my head, so I don't have to look it up and waste time. If I had thought about it before class, I would have pulled those numbers up, but I just went on a little tangent, and my tangents can be random. All right, so take that bonus. Don't worry about making more money. You're still going to make more money. Now, if all of a sudden your medical insurance goes up $200 a month, that's another story. All right, so Bob has to pay taxes, and he had 28% of his income withheld. So some of his money was taxed at 12%, some was taxed at 22%, some was taxed at 24%. He also had to pay his Social Security and stuff, which is extra money besides that. You also have state taxes, which in Virginia, it's like 5.5 roughly. California, it's like 13. I think that's the highest. And that's if you make like $1 million, to be fair. It's bracketed just like our federal taxes. So when all that is said and done, Bob had 28% of his money taken from him. And it turns out he had about 20 grand taken from him. And what we want to figure out is what is his annual income? So let's go ahead and try and make a prediction about his answer. What should the answer be in size? Should it be bigger than this 20,000 or should it be smaller than this 20,000? Well, if he has 20 grand, again, rounding, if he has 20 grand taken from him, I certainly hope that he made more money than 20 grand. Otherwise, Uncle Sam is leaving him in the red. If he only earns, say, $5,000, how would he have 20 grand taken from him? Because there isn't even 20 grand to take. So he's going to at least have to earn $30 or $40 or $50,000 for Uncle Sam to take 20 grand. If he earned $40,000, this 20 grand would be half of that. So that would be 50% singular, but this is 28%, so obviously he's got to make more than 40 grand. If he made $200,000, this 20 grand would be 10%, 20 out of 200, which that means he definitely didn't make 200 grand because he's being taxed at 28%, not 10%. So his actual income is somewhere between $40,000 and $200,000. Now that's just a small margin, but at least we have a good idea in case we did this wrong, for instance. So what are we doing? We're doing this part to whole proportion, where one side is going to deal with the numbers of his income and the other side will be a percent and a 100. This is automatic. When you're dealing with a problem like this, some percentage of some value, what was the whole, or you have the percentage and the whole, what was the part, anything like that, this is the first thing you should do if you're going to go with my method. So the right side is the percent, so that's where the percent number should go, which is the 28%. Now, some people will go, oh, okay, well, 28%, this is 0.28, so then they'll do this, they'll put 0.28 over 100, which is wrong. Because 28% as a fraction is 28 over 100. If you don't trust me, just put that in a calculator, and 28 over 100 is going to be 0.28. Remember, you've got calculators in real life, and this class is for real life. So be careful with that. That's one tiny thing to be careful with, that some people will convert this percentage to a decimal and then put the decimal here. But no, because this is a fraction representation of a percentage, the 28% literally means 28 over 100. So then the only thing is, where does this 19,880 go? Does it go here or does it go here? Which spot does it go? So what you have to ask is it the part or is it the whole? Is it the part or is it the whole? So is this roughly $20,000 part of his income or is it all of his income? Well, we hope that his income is more than this, so it would definitely have to be the part. So we can logic our way through it that way. The part always goes in the top, so thumbs up. We don't know the whole, that's the question in any type of proportion. We always have a variable somewhere, so you can use any letter you want here. X is my favorite traditionally, so that's what I'm going to go with. Now, if you can't conceptualize why that's the part and not the whole, here's our word of, and we said that the something after the word of is the whole. What's the something that comes after that word of? His income, not what the government took, his income. So this should be the whole, his income should be the bottom. So that's just an alternate way to have figured out which goes top and bottom. I'm giving you multiple methods. I'm giving you logic and I'm giving you word associations because I know some of us like logic and some of us like word associations. How do we solve this? Well, you know how to solve this. You better know how to solve this. You cross multiply, so you get, when I multiply the 19,880 by 100, it's just going to put 2 more zeros up there. So here's the times 100 part, which now makes that 1.988 million. And then that will be equal to 28x. To finish it, we divide both sides by 28, which will tell us that our answer is, drum roll, 1,988,000. That looks right, divided by 28. And we get 71,000. So 71,000 is equal to our x. Now remember, whenever you get an answer, that doesn't mean it's the answer. What is its income? If you say 71,000 this way, nope, that is wrong. Technically speaking, we're QR students. We know units are critical. Is it 71,000 apples? Is it 71,000 yen? Is it 71,000 bobs? No, it's $71,000. That was his income. I don't want to write X there. I want to say income. And it makes sense because he paid less taxes than his income, and this income isn't some exuberant amount. Like I said, $200,000. If you're taxed 20 grand, that's 10%, because 20 grand out of 200, if you did that division, you'd get 0.10, or 1/10, or 10 over 100, however you want to represent the number. So if I had done this wrong, if I had said the 19,880 was the whole for some reason, I'm just not thinking, I'm not paying attention, I'm doing things quick, I'm talking to other people at the same time, whatever, and I got everything else right, and you put your X there. When you cross multiply, you're going to get 100x is equal to the 28 times the 19,880. I'm going to go ahead and just write that. 28 times 19880. 556640, 556640. Then we'll divide both sides by 100. Again, this is wrong. Divide by 100. And we get 556640. 5566.40, since that's our money income. Question mark? We made $5,000, we made $5,500, and Uncle Sam took 20 grand? That makes no sense. How are we making $5,000 but Uncle Sam takes 20 grand? Now you might say, well, he's garnishing our wages. Even still, they can only garnish exactly what you make. And I hope you don't end up in a situation where your wages are garnished. Pay your taxes, be a law-abiding citizen, all that good stuff. I have another, just silly teacher / I guess dad joke, but I'm not going to say it for a recorded video. Y'all got to meet me in person if you want the dad jokes. What is 40% of 230? Oh man, this is just a boring math problem, isn't it? But I mean, maybe there's a reason you're doing this on your own terms. Maybe maybe you borrow $230 from somebody and they tell you that they want a 40% VIG, which means you've got to pay 40% extra a week later or a month later, depending on whatever their frequency is, or a year later, which is a significant chunk of money. But okay, if I want to borrow $230 and this guy wants another 40% on top of that, how much money am I going to have to pay him just for this loan? Well, you do 40% of 230. So you're asking yourself, what is 40% of 230? So again, this could have been paired with an actual problem, or it could just be a really boring math teacher coming in and saying, what is 40% of 230? All right, well, context or no context aside, we definitely cannot figure out which one is the whole or the part just based on logic and reasoning here. So that's why you have to know that the thing that comes after of has to be the whole. So that of memorization would be critical there. So we're going to go, oops, wrong color. It doesn't matter. 230 in the bottom. That'll be equal to something over 100. The 40% is the percentage, so 40 goes in the top, not 0.4, not 4,000. It's just 40. And then the part is the unknown. We cross multiply, and we'll get 100x is equal to 40 times 230. Will be 9,200. 230 times 40. 9,200. Just showing you that in case you didn't trust me. Divide both sides by 100, which we can just cancel two pairs of zeros. You don't even need a calculator for that. And that says that x is equal to 92. What is x? What units does it have? I have no idea. This problem doesn't give you any clues to that, so it's just x equals 92. Again, there's no context to this problem, so we can't necessarily make sense of it unless we're just really good with our numbers. We're numerate, and we know that this is exactly how the problem should have flowed. But again, in the real world, it's pretty rare that you're doing a problem on your own for no reason with no context. You're going to have context for doing this problem. The point is being able to set it up in the math terms and solve it, and making sure the answer makes sense. All right. Next up, 95% of students did not like today's quiz. So this is a very, very strong dislike. What quiz? It's not actually the quiz that you're doing today. Trust me, it was just a made-up statistic. So 95% of students did not like today's quiz. If there are 15 students, how many students didn't like the quiz? Now, we're going to get an answer, and then I'm going to say, I'm not telling you anything about rounding, spoiler alerts, but there would be a reason to maybe say the answer is different than what we actually get. And let's get to that point when we get to it. For now, let's set up a proportion. So fraction equal fraction, because we're talking about a percentage of something and some part or whole. So that's it. We're not talking about change, which leads us to things later in this section. We're not talking about years later, which leads us to things in another chapter. It's just fraction equal fraction still. Where one of the bottoms is 100, you can make the left bottom 100 if you want, as long as the 95 goes with it. The 95 goes with 100 because that's the percentage. 95 out of 100, that's what that means. 95 out of 100, or 95 per 100. That's what 95% means. There are 15 students. How many didn't like the quiz? So what we got to figure out now is this the P or the whole? Is it the part or the whole? The P or the W, the part or the whole? So we have 15 students and we're saying how many didn't like the quiz? So we're saying there's 15 students. Could 16 or 17 or 20 students not like the quiz? Well, no, that's not possible because I'm telling you there's 15 students. It's possible 15 students don't like the quiz, but it couldn't be 16 because there's only 15 total, so it has to be the whole. So the 15 has to go in the bottom. Now, another way you could have figured this out is the word of says the next thing goes in the bottom. So of students, that says the number of students goes in the bottom. Here's your number of students, so the 15 goes in the bottom. That's two different ways to set that up. Well, that makes this the x. We're going to cross multiply. So we get 100x is equal to 15 times 95. I'm not doing that in my head. I could if I had another 10 seconds. That's 1425. Finish this up. We divide both sides by 100. Told you don't get to forget how to solve those. And then 1425 divided by 100 is just going to make a decimal here, move left twice. You can show the division if you absolutely have to, but you will end up with 14.25. And for this type of problem, I'm going to say that this is not a great answer for two reasons. First of all, there's no units, so it's a horrible answer. So that says it's 14.25. What's the units? We're talking about students. 14.25 students, question mark. So we're talking about a very small population, 15, 16, 20, 30, even 100 or 200 students. And we're saying that 14.25 students don't like the quiz. You can't have 0.25 of a student. You can't have 0.25 of a student. So I would say this would be a problem where you should expect to just know, you should round this to 14 students. So it's not like one of these students, 25% of a student didn't like it, and then the other 75% of that student did like it. That's multiple personalities, and I'm not going to insult that or talk about that at all. I'm just saying that that would be like a comparison thing there. But yeah, and that's because we're talking about a small size. We're talking about a small population. This is where we usually round to whole numbers. Now, if I gave you a problem where I said, like, out of a population of 251,000, so 330,251,917, and then you had some percent, blah, 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 and then your answer was x is equal to 14.25. This is okay in this sense because we're talking about a very big population size. If you look at census statistics, they'll say something like the average household is 5.3 people or 4.7 people, something like that. It's a ballpark value, not using an actual statistic here. As you know, 75% of statistics are made up on the spot. Ha ha ha. That was a joke. A bad joke, but a joke. So I know you're like, why can I call it 14 here, but 14.25 here? Again, it's about the context and size of the problem. If we're talking about a small population, we generally round people to whole numbers. If we're talking about a massive population, we generally are okay with people having 1 or 2 decimal places. And I know that still you're probably inclined to say, well, 14 students here, but again, it's just a normalized standard that 14.25 would be okay for large population sizes. All right. There's that quiz peeking at you. 71% of the Earth is covered in water. This is not the quiz. If 140 million square miles are water, what is the total surface area of Earth? Oh, we're talking about percentages. We have one of the values, either part or whole, and we're looking for the other. We're going to set up a proportion, fraction equal fraction. All right, well, I know one of these fractions because we're talking about percentages. The bottom has to be 100. Also, if you like setting up proportion tables, you can do it that way. You can set up a proportion table with this. We are literally doing the same thing over and over and over. You can do a y equals kx with this, believe it or not, but I'm not going to teach it that way. If you figure it out on your own and you can always get it right, then do it that way. I just want to focus on the method that most people are more consistent. So 71% of Earth, that has to go with 100. That's automatic. Don't overthink that. The percentage goes with 100. 140 million square miles are water. So we're just trying to figure out, is this the part or the whole? So 140 million square miles are water. What is the total surface area of Earth? So we've got to ask, is 140 million square miles of water part of the surface area of Earth or all of the surface area of Earth? Well, think about this. What are you sitting or standing on right now? Are you in the middle of an ocean or a lake? And if you are, that might be pretty cool. But most of us, if not all of us, are on dry land right now. So no, water is not all of Earth. It's just part of the Earth. The total surface area of Earth is the whole. So the 140 million, just contextually using logic, has to be the part. Now you can write the 1, 4, and then all those zeros if you'd like, but why not just say that this bottom is in millions of square miles, and then the top would have to be in the same type of unit. So these are not rates of two different things. This is a ratio of the same type of thing, square miles to square miles, people to people, oranges to oranges. So here's our x, we cross multiply. Oh, and also the other way, 71% of the Earth is covered in water. 71% of, the next thing should be the bottom, the Earth. The covered in water part is not what's immediately there. That's another thing. It's saying 71% is covered in water. So of the Earth, that says the Earth is the whole, which makes the water the part. All right, so when we cross multiply, 100 times x is equal to 71 times 140. Definitely not going to do that one in my head. Where's my mouse? There it is. 71 times 140. And we get 9940. I don't know why. I just feel like that number isn't right. No, it is. I just thought I had a different number in my head. And then divide both sides by 100. Just making sure I didn't make a goofy mistake somewhere. And the same thing, dividing by 100 just essentially puts a decimal 2 places left. So that's 99.40. That is not the answer. If you just say that, that's wrong at 99.40 what? It's 99.40, or just 0.4. You don't really need the zero since we're not talking about money. Millions of square miles. And that would be of water. Does that make sense? Well, if there's 100, now I knew I was doing something wrong. So this is perfect. We did it wrong, and this is perfect. Does it make sense? No, it doesn't make sense, because the 100, and the funny thing is I was going to do this problem wrong after this anyway, so you're just going to see the same thing. The 140 million square miles are water, and we were asked for the total surface area, so of surface. That was the first thing I did wrong. So if there's 140 million square miles of water, how is it that the total surface area of Earth is 99.4 million? That includes the water and the land. So this has to be wrong. The total surface area of Earth should be more than the water, and that's because what I did wrong in this process, I talked out the parts and wholes correctly. I said that water is the part, this 140 million was the water, and I put it in the bottom. That was my mistake. Again, I was going to make this mistake after doing it right, so we just got to do it first wrong anyways. So that was fun. Again, this is the beauty of teaching quantitative reasoning, because I talked this thing up correctly the whole way. I made a simple mistake because I'm talking and writing and reading at 3 different speeds. Multitasking is how we make mistakes. But in the process, I analyzed my answer and I said that makes no sense. So we say that's wrong, and now we're going to set it up based on what we actually said. The 140 goes in the top because it was the part, the x goes in the bottom. And that's why when I was right here, I was like, something doesn't look right. So now when we cross multiply, we get 71x equals 140 times 100 is just 2 more zeros tacked on the 140. We divide both sides by 71. And that tells us that x is equal to 14000 divided by 71. And there we go, 197.13, blah, 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 blah. Let's just round to 2 decimal places, 197.18. But that's not our answer. It's supposed to be 197.18 millions square miles, and that's of Earth, or of surface area, however you want to phrase that. That includes land and water. That makes sense because 140 million square miles is water, which means then that leaves about 60 million square miles of land. Also, if you know anything about Earth, Earth is 71% water, just like people are about 70% water. So this would make sense. 140 is about 70% of 197. But there's so many different ways you could have just gotten this answer wrong contextually. If you forget the million, if you just say there's 197.18 square miles of Earth, that's definitely not right. There's more than that many square miles just in Virginia alone. It's more than that many square miles in just Hampton Roads alone.
All right, so we're going to go ahead and call it there. Like I said, we finished 3.4. We got into some of 4.1, but definitely didn't finish it. We talked about some details with the midterm. We talked about the project in great detail. As a reminder, those dates are the 25th through the 24th when I had recorded the section for the project. I didn't have those dates in mind yet. And then your due date is the 25th. And remember, you can be working on designing the formulas, the charts and everything while you're still going. In theory, someone could finish all of the details except just typing their numbers in by like the 26, 27, 28, something like that. And then just literally for the rest of the month, you're just, oh, I spent some money today. Let me enter my numbers. Oh, I spent some money today. Let me enter my numbers. Do not wait until the last second to work on that. It will be a bad, bad, bad time if you are still building formulas, still building charts, etc. on the 24th or 25th. But besides that, have a good one. We'll see you back for regular class for the week 6 lecture 1 video on Tuesday the 1st, I believe. Yes, that sounds right. And email me if you have any questions. Besides that, take care, everybody.